Hi everyone, I am Dr. A. Sedupati, Assistant Professor, Department of Mechanical Engineering, SNS College of Engineering, Coimbatore. Today we are going to discuss about in this video the velocity and acceleration diagram in machines. So we are using the velocity and acceleration diagrams in the part of theory of machine subject. So we are designing the machines through links and pairs connected with the mechanism. So this mechanism, how to work in the velocity and how it will be create a acceleration due to the between the link joint points and how to we connect in the points with the specific velocity and acceleration. So what is the capacity of machines that will create how much amount of velocity needed and how much amount of force we applied. So in these types of topics we will discuss in this video. So first, what is velocity and acceleration diagram in machines? So in this representation delves into the theory of machines, especially focusing on velocity and acceleration diagrams. So the aim is to provide a clear understanding of how these diagrams aid in predicting the performance and dynamic behavior of machinery, ensuring efficient and safe operation. We will look at both velocity and acceleration diagram. So in this velocity and acceleration diagram, the purpose is to save operation in the machines. So how much amount of load we will apply and how the velocity will be created and how it will be accelerated. So these type of portions will covered in this video. So first introduction of velocity diagram. So velocity diagrams we mostly use in the graphical representation method. So in this method is used in the relative velocity. So the relative velocity means we have the, for example, 4-bar mechanism. The mechanism have 4 links and each link have 2 joints. So each joints have individual velocities with represented in the previous point of joint. So in this type of calculation of velocity is called the relative velocity method. So in this method, we are using the point of velocity in the link with respect to another point. If the first point and the second point, we find the second point velocity from represented with the before first points. So this is the this is used in the different links and different machines. So it relies on the principle that the absolute velocity of a point is the vector sum of its relative velocity and the absolute velocity of the reference points. So this is the relative velocity method, how we will find the velocity in each points. So how it will be constructed? So the construction a velocity diagram involves drawing vectors representing the velocities of points in the mechanism. The length of each vector, that is called each links, represents a magnitude of the velocity, and the direction of the vector indicates the direction of motion of the link built in the machinery, and the diagram is constructed by starting with a known velocity. First we will find one link velocity. The problem will given in the RPM or rotation clockwise or anti-clockwise of the link and how much RPM that the link will be rotated. So in these data we will find the first link velocity, that is called angular motion of velocity. We will using the formula for we will use the formula for find the angular velocity. So what is the applications of velocity diagrams? Before the velocity diagram, how we will construct? We will find one link, first link angular velocity, and we will draw the velocity diagram through perpendicular to the direction of the link, which is go through the direction of amplitude. So we use the perpendicular joints from the point which we need the velocity diagrams. We connect first point and we will use the second point and third point. The second and third point will be intersect a point that is called the fourth point. So we will use this diagram to construct the velocity diagrams. So these velocity diagrams where we will use it. So widely used in analysis and design of mechanisms. They provide valuable insights into the kinematic behavior of machines. That is called the motion of machines, and allowing engineers to optimize their performance and ensure smooth operation in kinematic joints inside the links and the machines. So velocity analysis. So velocity analysis diagrams enable engineers to determine the instantaneous of the velocity of various points in a mechanism. So this is the velocity analysis, and mechanism design means by analyzing velocity diagrams, engineers can optimize the design of mechanism and how much amount of velocity will be created inside the links, and how much load will be withstand in these links, and how it will be rotate or how it will be worked. So these mechanisms are analyzed by the velocity analysis. Then performance of prediction, that is the velocity diagram helps in predicting the performance of machines by providing insights into the velocity variations of different components during operation. We have a machine, the machine has so many number of components inside to build the mechanism. So these mechanisms, how it will be variations of different components working in this machine, we will find from the velocity analysis. So the next one is acceleration diagrams. These acceleration diagrams are based on the velocity diagrams. We will find first the velocity, and the velocity will be converted into acceleration. So the velocity is meter per second. We will use the unit, and the acceleration is meter per second square. We will square the velocity values which we find before using the velocity diagrams. So we have two type of acceleration diagrams. The one is tangential acceleration and another one is the angular acceleration. So the tangential acceleration means it will be touch a point of contact in the which links used in the mechanism. So that tangential acceleration will be created by using the radian values. So the tangential acceleration we will before find the angular acceleration. After that we convert the tangential acceleration diagrams. So what is tangential acceleration? It is the component of acceleration that is tangent to the path of motion of a point contact. It is caused by the change in the magnitude of the velocity of the point. So the change of velocity which the point will be used. So this is tangential, and the centripetal acceleration, that is the component of acceleration that is directed towards the center of curvature of the path of motion of a point. It is caused by a change in the direction of velocity a point. The third one is Coriolis acceleration. We used mostly in the tangential and angular accelerations in the diagrams. So how it will be constructed for the acceleration diagrams? In graphical methods, the acceleration diagram will be used to find the angular acceleration in each links first, and use the angular acceleration to draw a parallel line where the links fixed. So the parallel lines we will use to convert the tangential acceleration lines by perpendicular to the links we were used in the mechanism. So the angular velocity is used by parallel of the link direction, and the tangential acceleration will be perpendicular to the direction of the links we fix points. So how it will be constructed, that is the involved determining the acceleration of various points in the mechanism and representing them as vectors. This diagram is constructed by starting with a known acceleration and sequentially adding relative acceleration to determine unknown acceleration. So known acceleration means angular acceleration, and unknown acceleration means the tangential acceleration. We will find the tangential acceleration using the angular acceleration. So these are the methods we are using and how it will be analytically used, and software tools where we usually to draw the acceleration diagrams. So what is the applications of the acceleration diagrams? That is the dynamic force analysis. The acceleration diagram enable engineers to determine the forces acting in the machine components, providing essential information for dynamic force analysis and mechanism balancing. The machine mechanism will be under in the balancing or unbalanced condition we will find from the acceleration diagrams and analysis. Then stress analysis. The acceleration diagram helps to predicting the stresses acting in the machine components, allowing engineers to design components that can withstand the stress without failure. So before designing the machine, we will calculate the stress values, and through acceleration and velocity diagrams. So this is the advanced methods to find the velocity and acceleration diagrams. So three-dimensional mechanisms, that is analyzing the velocity and acceleration of points in three-dimensional mechanism, requires more complex techniques than those used for 2D mechanisms. But these mechanisms involve using vector algebra and matrix methods to present and manipulate velocities and accelerations in three dimensions. Another one is CAD softwares. We will use the CAD softwares to find the acceleration and velocity diagrams. This is the conclusion and key takeaways. Why we are using the velocity diagrams and acceleration diagrams. So the velocity diagrams provides a graphical representation of the velocities of different points in a mechanism or links we are using in the machines. And acceleration diagrams provide graphical representation of the accelerations of different points in the mechanism used in the machines. So these diagrams are essential for understanding dynamic behavior of machines and predicting their performance. So we are using in these type of velocity and acceleration diagrams for the dynamic position of the machines. So these have wide applications of dynamic force analysis, mechanism balancing, and stress analysis. Thank you.